Final talk. The final paper of this session is UCM, fast and maintainable user space RDMA connection setup. The presenter is Huijun Shen. She is a fourth-year PhD candidate at Hunan University. His advisor is Professor Guo Chen. Her research focuses on deployment and optimization of RDMA-based high-performance networking protocols and AI infrastructure architectures for next-generation systems. Let's start it.
Okay, thanks, Professor Tian. Hello, everyone. I'm Shen Huijun from Hunan University. Today, I'm going to talk about UCM, fast and maintainable user space RDMA connection setup. And here is my co-authors from ByteDance and Hunan University. We all know that RDMA is a de facto standard for high-speed networks in modern data center. It is widely deployed in many productive apps like storage, recommendation, large language model in inference and training. For RDMA connection setup, there are two usual approaches. The first uses traditional socket APS, the same as regular TCP. Well, the second leverages RDMA CM APS for the lib RDMA CM library. Just to add, the CM APS are based on sockets but adapt for QPair-based semantics. Here's the key difference. The socket approach exchanges QPairs and other resources through a separate channel, completely different from the following data paths. Hence, we call it out-of-band connection. Well, the CM1 shares the same path with data transmission, and our analysis focuses on transmission efficiency, so we'll mainly talk about this in-band connection today. Let's see the whole process of RDMA transmission. The notable high performance of RDMA that we always talk about is referred to the right part of the picture with green lines. We call this RDMA fast path or data path. However, RDMA's control path at the left part of the picture is pretty low because it has to manage connections by kernel OS. When we focus on why RDMA control path costs so much, the most important part is the connection setup process. Because RDMA CM needs kernel driver to communicate with the RNICs for the packet processing. So during CM connection, there are a set of CM control options which are invoked through system calls to the kernel. However, these kernel calls are all long and difficult to observe. That makes RDMA connection setup process is inefficient and difficult to monitor. Specifically, we can see the inefficiency of RDMA connection management in these two metrics. First, for one single RDMA transmission, the latency of connection management is around 1 to 2 microseconds. Which is much higher than real data trends we can see from the left picture. Then the high cost of RDMA CM will be worse with the increasing of connection number. As we talked earlier, the traditional RDMA CM depends on Linux kernel calls, which is complex and non-transparent. When we meet an RDMA connection setup warning or error from user, there's no ideas about which QPair, which step, or which parameter. We have to take a lot of time reproducing, coding, even guessing. All of this lead to such a long resolution cycle, no matter bugs in lib or kernel. For most high-speed of productive apps with high latency requirements, that's intolerable. So our goal is to develop a new user space RDMA CM setup approach. Here is the original RDMA CM in Linux kernel. And we have two insights. One is to choose RDMA CM connection. because as we talked before, it has unified APS and its in-band features which can help us to detect some potential path issues during the connection setup process before the real data transmission. The other is to leverage some recent user-space technologies like DPDK or some LibOS stack mode. That's our design, UCM, user space RDMA connection management. We can see in this picture, we want to make sure the whole CM process in user space only. Here's the UCM detail. UCM framework has two main models. One is work model and the other is monitor model. In work model, we set up and manage RDMA connections in user space, and in monitor model, we offer many methods to monitor and observe the UCM packets. Well, specifically in UCM work model, we met two challenges. The first one, how to implement the kernel-bypass, and the second, how to support multi-thread for better performance. For the first question, we manage connections bypass kernel in our UCM library as a LibOS library, which share the same address with user applications. And we leverage DPDK to handle packet processing, which means we can communicate to the NICs in user space without kernel. And for the multi-thread scenario, UCM leverages lock-free management. We use the flow steering features, which supported by most NICs. In this way, we can separate CM requests to different threads with QP number. We make sure that each connection's related information is accessed and management by only one thread. Well, in UCM's monitor model, we add some tracing cribs with USDT to get more information about connection status. And we also develop a capturing tool in UCM library for tracing UCM packets. Well, in our test bed like that, we evaluate UCM with these goals. First, we compare UCM's connection setup speed with the SOTA approaches, like the original RDMA kernel CM and SECM. Well, second, we evaluate the impact of UCM's maintenance overheads on our productive applications. At last, I will showcase some successful maintenance experiences with UCM. Well, first, we deploy UCM in a large RPC framework in ByteDance. We can see in the picture that UCM performs many times better than the traditional kernel model. The extra overhead with enable our monitor platform is cost less than 7%. Well, now I will show some efforts from our monitor platform. With the UCM's monitor system, we can know the latency of every operation in online communication, in online connections, and we can see which one is the bottleneck in the UCM's process. Well, also we can, when we got some optimization and modify of one single option, we can also see the comparison of the bottlenecks operation. We can know whether the optimization works or not. At last, we can see we have two related works, KR Core and SECM. Our UCM need no special support from apps and RNICs. There we can get a conclusion that UCM is the first pure user space RDMA connection management framework, we got dramatically accelerate RDMA CM setup efficiency, and we offer better maintenance for the RDMA production applications. At last, we hope that UCM will inspire more possibility for optimizing the RDMA stack at software or at user space. Thanks. Thanks for your listening.
Okay. Yeah, I have one question. Yeah.
I worry about security, isolation, and fairness when you do this.
Sorry?
So you're having user space set up the queue pair.
Yeah.
I don't know if this is a dumb question, but I worry about security where you have user application setting up and you can starve out others, and how do you deal with fairness?
Okay, I got you. You are focused on the security when we put the queue pair management in user space, right? I think this question is related our background. Our design now is only deployed in our own company, so I think the user we all already trusted. So we
So we offloaded this task onto a DPU and provided isolation. Might be helpful to think about that. Offline.
Okay. Maybe we can talk offline.
Okay.
Oh, one more question. Yeah.
Thank you for talking. I'm Wenxue from HK University. I have a question about what's the difference between your proposed design and the DPDK, and did you compare your design and DPDK, for example, bandwidth, latency, or I think the CPU saving is different?
You mean our design between DPDK?
Yeah.
I think our design is not some difference with DPDK. We just leverage DPDK to process our packets. We are not against DPDK. We have no performance compared with DPDK.
But I think the naive DPDK is that all control plane and the data plane are all in the user space, but your design, is that only control space in user space?
Yes.
Okay,
yes.
Okay, I see. Thank you.
Thanks.
Okay, that's all for this session. Let's thank the speaker again. Okay, so now I think we have a break till 11 o'clock.